Students, today I'm going to start with the course Basic Electronics, where we are going to continue with the Module 1 Semiconductor Diodes and Applications Part 2. So, what are the topics I'm going to cover here? It is the summary of the last session and what are the diode parameters, Zener diode and VI characteristics, and Zener diode as a voltage regulator, and a simple problem to illustrate Zener diode as a voltage regulator. So let us have a quick summary of the last session. As we have seen in the last session, how a PN junction diode is formed with the help of a P-type material and N-type material, and how it is diffused in order to form a PN junction diode. And also we have analyzed the PN junction under various biasing conditions. And when the diode is under reverse bias, we have seen that a natural barrier potential is developed across the depletion layer, and it is approximately between zero point 0.5 to 0.7 volt for silicon diodes, and it is 0.3 volt for germanium diodes. And also we have seen the operating conditions for a junction diode as the forward bias and reverse bias. During the forward bias, we observe the diode acts as a short circuit and the thickness of the depletion region is reduced, and it allowed the current to flow across the junction as well as the circuit. When the junction diode is reverse bias, the thickness of the depletion region increases and the diode acts as a open circuit, blocking any current to flow. And also we have seen there were flow of some leakage current which were due to the minority charge carriers exist across the junction. So followed by that we are going to study what are the parameters of a diode. The first parameter is the knee voltage or forward voltage, the point at which the forward current starts increasing exponentially. We'll call it as knee of the curve, and the corresponding voltage is called knee voltage. The second parameter is maximum forward current. It is the maximum flow of current obtained when the input voltage exceeds the knee voltage. Reverse saturation current. The constant reverse current flowing through the diode when it is reverse bias, will name it as reverse saturation current. The next parameter, reverse breakdown voltage. When the reverse voltage is increased at a certain value, the breakdown of the diode occurs and the reverse current flows very sharply. This voltage will named as reverse breakdown voltage. Power dissipation. So during biasing, the power that the diode can dissipate is called power dissipation. Static resistance or DC forward resistance. This is the forward resistance of a PN junction diode when a PN junction is used in a DC circuit and the applied forward voltage is a DC, and it is denoted by capital letter R with suffix F, RF. It is also represented as ratio of the forward DC voltage to the forward DC current. Dynamic resistance or AC forward resistance. It is the resistance offered by the PN junction under AC conditions. It is denoted by the letter small rf. RF is also represented as ratio of change in the input voltage applied to the corresponding change in the forward current. It is also represented as reciprocal of the slope of the forward characteristics. The next parameter is peak inverse voltage. Peak inverse voltage, it is the maximum voltage applied to the diode in the reverse direction without causing any breakdown of the diode. Maximum power rating. The maximum power that the diode can operate safely without increasing the junction temperature above its limiting value will call it as maximum power rating. So these are the various parameters associated with a PN junction diode. Zener diode. As we have seen in the last session, there are various special kinds of diodes available. So one such kind of diode is a Zener diode, which we are going to study here. So Zener diode, it is a diode which permits current to flow in the forward direction as normal, but will also allow it to flow it in the reverse direction when the voltage is above a certain value. This certain value will call it as a breakdown voltage, which is also known as Zener voltage. Mostly all the Zener diodes have a highly doped PN junction. So we can define the Zener diode in the other way, like it is a diode which can be operated continuously in the breakdown region without any damage being caused to it, and it operates in the reverse bias condition. Below this, we can see the appearance of a Zener diode and its symbol. So the symbol, if you observe, it is similar to the PN junction diode, like the P type is represented by a triangle and the N type is represented by a vertical line with up and down slightly bent, representing the reverse Z letter, which stands for Zener diode. Coming to the applications of the Zener diode, it is used as a voltage regulator since it maintains a constant output voltage even though the current through the Zener changes. Let us see how the Zener diode characteristics are. So here, as I told, the Zener diode, it behaves as a PN junction diode when it is forward biased, and the main operation of the Zener diode lies in the reverse bias. So as I told you, you can observe in the graph, the forward bias region will remain the same, whereas the Zener diode, it is being operated in the reverse bias. So as soon as the reverse voltage is increased, the Zener diode will remain uh, as a PN junction diode till it reaches the breakdown voltage Vz. Whenever the reverse bias reaches the breakdown voltage Vz and the current is varying from Iz minimum to I max, there is a steep increase in the current from Iz minimum to I maximum, causing a Zener breakdown in the PN junction diode. And even though you increase the current, the voltage will remain the same. Thereby, it will produce a constant output voltage across the diode. And this is because of the process, we'll name it as an avalanche breakdown. What is avalanche breakdown? It is nothing but when the diode is operated in the reverse bias region, the reverse voltage, once it exceeds the rated voltage of the device, a process called avalanche breakdown will occur, thereby it creates more number of charge carriers, thereby a major current flows across the diode, and this current can be limited by using a resistor across it. I can define the voltage at which The Zener breakdown occurs, we can name it as a Zener breakdown voltage, and mostly it is in the range of 4.3 volt or 7.5 volt.